Today in this video we're going to talk about how to solve an exponential equation in two different ways. First way using nSolve, second way using graphing, and we'll also use the graph of an exponential function to compute function values. So this is the problem that we're going to look at. Right, we have a current flowing through an electric circuit. We have a formula for its value after t milliseconds, and we're asked a bunch of questions. Okay, so really part B and part D are the ones that we're going to focus on, assuming you know how to graph already, but we'll go over that anyway. So let's get to it. Part A, this is an easy one. Find the initial current in the circuit. So for me, initial value means the value in time is 0. So if we just plug in 0 here, this part of the equation turns into 1, right? Because any non-zero number raised to the 0th power is 1. And so the initial current in this case is just 320 milliamps. Okay? Easy, right? So that's the answer there. All right, next. There are different ways to do this, but we want to find the current at two different times. So the way I'm going to show you in this video is to graph this and use the trace feature. Okay? So this is all on the Nspire, but the first thing we need to do is put this equation in and get a good visual of it. So to do that, I'm going to go to the graph option in Scratchpad. I'm going to type in the equation, which was 320 times 2 raised to the negative 0.5. Okay, so 320 times 2. The caret button here is what we can use to do exponents, and this was negative 0.5. Now in the formula they're using t for time. We're going to use x here. Okay, so that's our equation. I'm going to push enter, and we don't really see anything, and the problem is, right, if we look at our scale, right, basically the y values are way too small. Okay, and the way I like to adjust things on the Nspire is we can hover over a number that denotes the max or min of the x, or in this case the y-axis, and we do a slow double click. So I'm going to change this to 500. Okay, and then I'm going to push the tab button, and what's cool is we can just go around this graph and it'll auto update. So actually that looks pretty good there, right? Maybe if I want, I'll go out to 30 here. I'll push tab again. Okay, now I have a pretty good picture of the graph, so I'm just gonna escape out because I like this picture. Okay, so actually now we can do graph I, or we can do part C, graph I against t. You know, we have the picture. Maybe we want to show this point, the y-intercept, but we have a good visual. Okay, and if you want to get some more specific points, that's what we're going to do right now. Let me just grab this, get out of this way. Okay, so how can we find specific y values quickly? There's a bunch of ways. I'm going to use trace, so we want the value at 4 and at 10. Okay, so push menu, go to the trace option, graph trace, and now right here you can see that it's on a point. All right, I want the value at 4, so literally I'm just going to push 4. We get this notification that x is 4. You push enter, it'll move the point and it'll give you the value. Okay, so at x is 4, the function value is 80. Okay, so that's the answer to this question, and we can see right there, right? At 10, pretty easy. I'm going to do the same thing. I'm going to go menu, trace, graph trace. It's not going to prompt me for anything, but I'm just going to push 1, 0 for x is 10, hit enter, and yeah, there we go. At 10 milliseconds, I believe it is. Yeah, the function value is 10 milliamps, and we can confirm that right here. Okay, so the nice thing I like about this too is, for example, if we want, even if we can't see the point on the graph, the calculator will compute the value. So let's hope I don't regret this. So if I go to trace and I want to know the value at x equals 100, right? I can do that, and you can see it auto adjusted. So it's a really small value, and it's changed our whole view of the graph, but that's kind of cool, I'm going to try and go back to 4 because I want to see a better picture. Okay. So let me adjust this graph just a little bit. All right. So nice, easy way to find function values using trace. Okay, now the last part here is use tech to find how long it takes for the current to drop to 50 milliamps. So now we're given a function value. We're given the value of I, and we want to know how to find t. Okay, so the way to do this graphically, we can push menu, analyze graph, and go to intersection. And I don't have a second graph, so let me go and put a second graph in. Right, so this is the function y equals 50. Why is that? Well, that's the value that we want to know. Okay, and once we see where the two graphs intersect, we can just go menu, analyze graph, intersection. Lower bound, you can either move this line using your touchpad, right? Or you can just guess a number. So I'm actually just going to guess for the lower bound 0. Okay, it'll position the line there, and we want to, we want to be in between these. So for my upper bound, I'm going to guess, I don't know, 20. Okay, and you can see it found the intersection point. So in this case, when x is 5.356, the function value is 50. So that's the answer to part D. And we see right here 5.36 is the value. All right, so if that was enough, that's how you can solve exponential equations using the calculator via graphing. I'm going to show nSolve if you want to stick around, because that's another option. But the danger with nSolve, right, is if you have multiple solutions, it's only going to find one. So you sort of have to know what your graph looks like. We can see from here, there's only one value where the function is equal to 50. So if we know that, right, we can use nSolve. And the way we do that, we push menu, algebra, numerical solve. Okay, then we're going to type our equation that we want to solve in. So that was 50. The equals button is over here to the left of the 7. 30 times, I think it was 0.5, right? That was the, hope that's right. No, it's 2. Jeez. And it's not 30, it's 320. Okay, so guys, you see what happens when you get old. You forget stuff really quickly. So it's 2 to the negative 0.5x. All right, so this is 2. I'm going to use my caret. Negative 0.5x. All right, and I hope the calculator is going to read this. I use the subtract button and not the negative button, but usually on the nSpire it doesn't matter, so hopefully this will work. Okay, so the last thing with nSolve is you can't just put the equation, you have to put a comma and tell the calculator what variable you're solving for, which in this case is x. So we could have used a t if we wanted to here, but I just like the convention of using x. Okay, that's it. So this should solve. I'll push enter. There you go, 5.356. That's what we had on the graph, and that's also the answer. Okay, so that's a lot in that video, but hopefully it was helpful, and yeah, see you on the next one, guys.